Hi, good morning everyone. Now in this session we will study about finding the area of triangle with help of determinants. In previous session we already have studied about how we are finding the determinants of order 1, 2 and 3 with help of cofactors. Here we already have the area of triangle which you studied in your class level in coordinate geometry. Half x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2, where x1 y1 x2 y2 and x3 y3 are the vertices of a triangle. So if all three vertices are given, we can find the area of triangle using coordinate geometry. We have the formula. Now here we are going to use the determinants for the same area of triangle. The same thing we can write as x1 y1. This is first vertex. In second row x2 y2, and in third vertex x3 y3. Now in third column 1 1 1. This value will be same as what we studied in coordinate geometry. As I told how we are finding the determinant, look here. If you are selecting the first column, first element is x1. x1 into the cofactor. Here cofactor is y2 minus y3. By deleting the first row and first column, x1 into y2 minus y3. This is the first, x1 into y2 minus y3. Same for the second, we will have y3 minus y1. For the third, y1 minus y2. So this is how we are finding the area of triangle with help of determinant. As area cannot be negative, so whatever you are getting the result after finding the determinant, you must check whether it is positive or negative. If it is positive, then that will be the answer. If it is negative, then you have to use the absolute value, means it must be in positive. So just look on this. First, what is area? Area is a positive quantity. Always it should be positive. Area is a positive quantity. If you are changing the position of vertex A, and this vertex A is here, then these points are collinear, B, A, C, collinear. In that condition, area will be 0. So for three collinear points, area of triangle will be 0. So area of triangle is 0 for three collinear points. If points are collinear, then area of triangle will be 0. Now next, as I told, area will be positive always. So if we are getting here the determinant negative, then you have to use the absolute value. So if area is given, area of triangle is given, then you have to use both positive and negative values for the determinant. If area is given, then use both plus and minus, positive and negative for calculation. This all we can understand with help of some examples. So let's start with the example. But here must concentrate how we are putting the value of vertex x1, y1, x2, y2, x3, y3. So I am starting with one example in which I am going to find the area of triangle. Find the area of triangle with vertices. You can select any vertex, 1, 3, 0, minus 1 and 2, 5. So using determinant, here we can write the area of triangle, or you can write area of triangle also, equals to half determinant. Under the determinant we have to represent all these x, y. First 1, 3, 0, minus 1, 2, 5. Then in last column 1, 1, 1. Now simplify. Directly also we can simplify. Half. Just try to select the row or column in which you have 0. Just here I am using the first column. First element is 1. With 1 delete the row and column. So minus 1 and minus 5. Here simply I am writing all the elements, minus 1, 1, 5, 1. Then plus second element is 0. With 0, if any number will have, result will be 0. So no need to look for the element which having 0. The last 2. With 2, 3, 1, minus 1. So this is half 1 minus 1 minus 5 plus this will be 0 plus 2 into 3 plus 1 half minus 6 into 1 is minus 6 0 plus 2 into 4 8 half into 2 equals to 1. This is the area of triangle with the vertices 1, 3, 0, minus 1, 2, 5. 1 square unit. 1 square unit. After solving, if your answer is minus 1, you must have to use the absolute value, which will be plus 1. Means final answer should be positive only. So here 1 square unit. This is one example where we are finding the area of triangle with help of determinants. Now just using same we can find the equation of line. Now look for second example. How to find the equation of line if 2 points are given? Find the equation of a straight line joining the points. You just select any 2 points, minus 1, 2, and 3, 5. Joining the points, it means in solution 2 points we already have, -1 to first point and second point is 3, 5. Now to find the equation we need the variables x and y. So consider any point anywhere on the line whose coordinates are x and y. Consider as C. As A, C, B are collinear points, so area of triangle will be 0. Area of triangle ABC equals to 0. Now for area of triangle, just use determinant property, half here, first point -1, 2, second point xy, you can use any other also, xy, and the last point is 3, 5. What about the last column now? 1, 1, 1 equals to 0. Now solve the determinant. You will get the equation of straight line AB. So here I am solving by taking either first row, second row, first row, by expanding the first row along first row. So here half -1 into the cofactor of -1 by deleting the row and column, y -5. Then second element +2 and the cofactor, relate the here x -3, and in cofactor you must have to take care about the position of element. Here position is first row and second column, first and second, 1 plus 2, 3, odd, so minus, here we will have minus, so directly here I am writing minus, x -3. Then for the last, 1 into the cofactor, delete corresponding row and columns, 5x minus 3y equals to 0. Now simplify. So here this is minus y plus 5, half will be 0 now. Finally minus 2x plus 6 plus 5x minus 3y equals to 0. Now in further simplification, look, all the x, 5x and minus 2x will be 3x minus 3y and minus y minus 4y, and the rest all constants, 5 plus 6 plus 11 equals to 0. This is the equation of line joining the points -1, 2 and 3, 5. This is how we are finding the equation of line with help of determinants by applying the area of triangle using determinant method. Now in third example we will discuss if area of triangle given, then as I told, if area of triangle is given, then for calculation we have to use both positive and negative values. Now third example, if area of triangle is 35 square unit and vertices are how many vertices we needed? 3. A, B, C. 35 square units and vertices are 2, 6. You can select upon your choice also. 2, 6, 2 minus 6, 5, 4, and with a variable so that we can find the value of that variable. K, 4. If area of triangle is 35 and these are the vertices, find the unknown value K. So same type we will use the area of triangle using determinant method. Area of triangle directly I am using here half. First point 2 minus 6, 5, second point 4, and third point is K 4. Here 1, 1, 1. Area of triangle given here 35. As we are using the determinant, so here we have to use plus minus 35. For calculation, we have to use plus minus 35 because I told about the area. Area will always be positive. Just look here. If the result of this determinant is 70, what is the area? Half into 70 will be 35. If the area or the value of this determinant is minus 70, if you are getting minus 70, what will be the area? Minus 70 by 2, minus 35. Area cannot be negative. So finally our answer is again 35. So this 35 means we can use both the values plus 35 and minus 35. So plus minus 35. Now by expanding any, just expand the first column. 2 into the cofactor, directly I am writing the cofactor now. 2 into, delete the row and column, 4 minus 4 is 0. Then next 5 plus 5, cofactor, minus 6 minus 4, minus 10, and then as per position this will be plus 10. And the last is K into minus 6 minus 4, again the same, minus 10. Just multiply this, plus minus 70, and now simplify. 0 plus 50 minus 10. So now either plus 75 or minus 75. We have to work for both the values. So first with plus, if it is plus 70, 70 equals to 50 minus 10. Now simplify for K. 70 minus 50 equals to minus 10K. 20 equals to minus 10K. So K equals to minus 2. Or now if minus 70, minus 70 equals to 50 minus 10K. So this is minus 120 equals to minus 10K, or K equals to 12. So we have these two values. Hence K equals to, both the values are applicable there, minus 2 or 12. Yeah. So these are the applications of determinant we can use in finding the area of triangle. We can use the same to find the equation of the straight line where 2 points are given, and we can find the unknown value if area of triangle is given in this way. That's all for today, and in our next session we will study about the properties of determinants. Thank you.